Right. Chapter 6, Section 2. We're going to learn about amplitude, period, and phase shift. Okay? Amplitude, period, and phase shift. When you're looking at a sine wave, think about it this way. A sine wave is like sound. If you're going to amplify amplitude, if you're going to amplify, what do you think is going to happen to that wave? It's going to get bigger, isn't it? Okay, let's do sine of x. But this time, let's put a number out in front of it. Let's say this 2, right? Sine x. And watch what happens. It still is going through at the same spots. It's still crossing the x-axis at 0, at pi, and at 2 pi. At negative pi, and at negative 2 pi. But what happens to it, like you turn up the volume on your stereo, it amplifies that sound. It's making it bigger. And that's what's happening here. It's just taking those sound waves, or those waves, the sine waves, and they're making them bigger. That's amplitude. That should be a real easy one for you guys to remember. All right? What happens now when I have a period in that? We've got amplitude that makes it louder. A period, and here if we adjust the period on this, notice the amplitude, we just multiplied it by a number outside of the sine. If we take the sine wave again, but now this time put the number inside. In other words, it's part of what we're doing here. I want you to notice what happens. All of a sudden, my period, it's happening at a faster pace. Okay? The period in which it's happening is faster. So you're happening in here. It's now at crossing at 0, negative pi over 2 and pi, or 0, pi over 2, pi. It just took this period. The period here was actually a pi, and it shifted down to pi over 2. Or if you want to look at it as what you guys did, when you put in the, let's say from 0 to 180 or from 0 to 360, if I looked at just that period in time, all right, if you take a look what happens here, let's turn that one off. Let's turn these off here. If I look at this here, get rid of this one so we don't have a mess. If you look right here, from 0 to 0 out to 2 pi, that's 3 pi. I don't want that. Where's my 2 pi? There it is. All right, from 0, 0 out to 2 pi on a regular sine, that's one period. It's made its whole sine wave. That's the period that it made it in. Now when we multiplied inside this by 2, it took that period and shifted it to half of it. Now the period for this happens by pi. My whole sine wave happens by pi instead of 2 pi. What would that make? What would that sound like? If you were going to do that, if you were going to take a sound and you were going to multiply the period in that by 2, what do you think that sound would be like? It would happen faster, wouldn't it? It would start happening faster and faster and faster and faster. It wouldn't be getting louder. It happens faster and faster. All right? What's that? Maybe, yeah. Your voice maybe would get higher. Okay? So if I took this number in here, and now instead of having a 2 in there, I put a 0.5 or 1/2 in there, look what happens to my period. It starts extending out. Now you may be getting a lower voice. All right. You're getting that lower voice. It extends it out. Okay. Okay. So you get a feeling of what happens. So amplitude, I can make it louder or softer. Louder or softer. And my period is how fast that wave happens. When does a sine wave go through? When does it complete its sine wave? And by giving it a number greater than 1 in here, it makes that higher. It shrinks down that period that is happening. Okay, by making it a fraction in here, we've actually taken it and extended it out. We made the voice lower. Okay. The last one we need to have is called a phase shift. And I've talked about this. A great example of a phase shift is between cosine and sine. If I take a look at the cosine of x, oh, didn't want it right there. Silly me. Okay. Cosine of x. There's a phase shift here. What's happened is we have moved this over by a pi over 2 or 90 degrees. Yeah, cosine will do the same thing. Cosine and sine are the same thing, but cosine is just a phase shift over. So how could I make this cosine right here, how could I do it with sine? What would I have to do with sine in here to make it look like a cosine? What? Inverse it? No. Danielle, what would I have to do to make my sine look like a cosine? I got a phase shift now, a pi over 2 or 90 degrees. I got my sine here, and I'm going to do x plus 90 degrees, but we're in radians on this right now, so it's pi over 2. Pi, where's my divided by 2? Divided by 2. All right, so what I've done here is I've created cosine just by calling it x plus pi over 2. I've done a phase shift of 90 degrees, or pi over 2. I phase shift this over. So by adding, same thing. Yep, if I subtracted this instead of adding, I subtracted. Oh, what happens? Does it do the same thing? It phase shifted over. But notice what happened. Here's where it's doing the opposite of what the sine is, isn't it? What if I did this at, instead of pi, 3 pi over 2? Well, think about this right here. Think about this right here. If I move it over pi, it's not the same thing as moving it back. Or, pi over 2, if I move it over 90 degrees, it's not the same thing as moving it back 90 degrees. I'd have to move it back 270 degrees. And that's 3 pi over 2. And that's what I've done. I've rotated it back around. Okay? So there are phase shifts. And what it did is it took my sound wave and it moved it different ways on the graph this way. That's sine and cosine. Okay? Which are fun to work with because they're so simple. They're so similar. But now what if we get into tangent? What happens in tangent? It's a little bit different in animal. If we take tangent of x, all right, and we do an amplitude. What do we do when we amplitude? It makes it louder, but if we take tangent of x here, we put, let's say, a coefficient out in front of it. So we'll make it 2 times tangent. What's going to happen? What happens? It actually starts narrowing it down. It makes it more of a straighter, it straightens it out a little bit more. Right. Well, tangent you can't use as a sound wave. It's not a sound wave. Let's put a bigger number on there and see what happens. Really starts straightening it out, doesn't it? No. It'll never be a straight line. Negative? We put a negative out in front of this? Moves it around the other way. No, it's not. It actually would have just a little curve to it coming out of this. Okay, so now we've looked at amplitude and tangent. Amplitude will make it narrower or it'll make it wider. If I put a half in there on my amplitude, it would make it wider, go wider. All right? What happens on tangent? Oh, I did it again. Hate it when that happens. Okay. What happens when I take my tangent and I do a period shift on this? Ooh. Let's make it 2x. Kind of the same stuff, doesn't it? It hasn't moved it over at all. It just made it narrower. Same thing as amplitude. It is what it is. It is what it is. Okay. It added something? Oh, you take a look, it put it in between here, didn't it? Yeah. So hey, it took it, and this I didn't even pick this out when I first looked at it. It added it in here. So what it did, it took the lines, put them closer. So the period, just like sine, just like cosine, brought them in closer, right? The waves are happening more often, more frequent. That's what's happening here too. What do you think is going to happen when I put this outside, or I put an x plus something in here? Phase shift. Just going to move it over, isn't it? Move it over. I move it over pi, no, not plus, divided by 2. All it did was took it and moved it over 90 degrees. Yeah, because it happens every pi, every 180 degrees it's shifting. Okay, so you got to look at what period is. Tangent to x, and a phase shift, tangent of x plus pi over 2. Okay, and we can do this for sine and cosine as well. I don't know. Let's take a look back on page. Oh, yeah. Yeah, I always put a graph. I'm going to have you graph. I'm going to have you. I'll do that. I don't know. We'll see. State the amplitude, period, and phase shift for each function. That's just not interested in that. All right. 35 through 42 on page 316. What I want you to do though is I want you to know what this looks like. Page 316, 35 through 42. 316. 35 through 42, is that what it was? Doesn't seem like enough. Yep, 35 through 42. Okay?